Hello, welcome to the another tutorial for robot drawing applications. Yeah, so today we will design a simple drawings for robot drawing applications. So first of all, what we would like to check is we have to check at the machining and make sure we are selecting our robot kinematics module. So to do that, we just go to the machining and this is the first layer. Just double click it and go to the machines, and we would like to choose the robot's kinematics that we prefer. So right here we can go to the include, and we can look for the files. And we try to look at the files that we want. This one is a folder. Now okay, so this one is the one that we want. I press OK. Now the robot module will appear. Okay, now let's back to the model. You can toggle on off the robot model if you want. Yeah, before that, first of all, I would like to talk about this robot positions. So as you can see here, when I try to import a new kinematics, the value of A1 to A6 represent the home positions of robots, but this is not a very good positions because this will trigger a singularity at robots. So what we want to do is we want to go to the machine maker, okay, at the machine maker we can just double click to the robots and go to the simulation. Now we can set the home positions. So let's say this is 110, 7, 0, 1, 7, 0. This one should be 10, and this one should be -1, set as home. So as long as this is set at home, we click apply. We just save the kinematics. We close the window. We reset the kinematics by double clicking and find the files or find your kinematics and press OK. Now this is not updating, so you can click again. Just double click, include the file. This one, folder. Okay, why it's not changing? Maker. Okay, just export the scheme to program. Okay, and right now it's already updated. So R2EDU empty. So this is the one. Okay. So right now we already have our models ready. We just go to model now. Toggle off. Now we have to make sure that the directions that we want to design is the same as the direction of robot motions. Okay, so go to the top view. As you can see, the X is pointing to the right and Y is pointing upward. You have to off this one. Now this is my habits. So for what I will do, I will just design. Go to design, model, design. Okay, XY plane. This one, right click, sketch. Now I will draw a boundary. Okay, you can select the box by 2 point. Click on it, select the boundary, create a boundary that is representing your drawing zone. So for example, I want to use a 200 by 120 boundary. That's all. Just click back and back. Now we want to do some text. So just click on the text icon here. Then you can start do some text. So robot scope data. Okay, for example, I want to type this welcome. Now we can use the text tool. Angle, we have to rotate it to 90 degree. Then we can choose the font if we want. You can choose the font you want. Then you can adjust the height or the width. Style. This one is affecting the spacing. Also, you can make your writing into italic if you want. Okay, after that you can just go to positions. At the start point here, you can just highlight and use your mouse to scroll so that it can move to a location that we want. And you can move on the y-axis as well to align. There's also an alignment here. You can choose left, center, or right. Okay, depends on the things that we run. For example, if I have another sentence, then we can choose to align it at the center. Then we can try to change our start point again. Okay, if that's done, we just click apply, press OK. Now we have our drawings and our work zones ready. We can go to machining. Now in machining, as you can see, the drawing right now is currently located below the cell. What we're going to do now is to move this drawing to the surface of the cell. What we're going to do is we have to go to setup. No, we try to make a workpiece first. So right now we can just off the robot module, off the robot kinematics. Then we use extrude, select the boundary, key the thickness of our plate or paper. You can just click a certain value. For example, I just click -3. Then the stock material will be created. After this, we have to go to set up and bring our material to the table. Okay, so before that we have to move our robots to a certain position that we want to pinpoint as the origin.
Okay, to find the base of where should we start machining, we just have to jog the robots. Okay, and use the point, the marker pen tool, to pinpoint the starting point that we want. Okay, so that is the base that we want to do. So we just jog the robot. Okay, and then we have to make sure that we select the tool that we have calibrated for this tool, which right now is tool number 6, drawing pen, and the base selection we have to use null frame. Okay, so that it can calculate based on the world of robots. Right now we just need to record the X, Y and Z positions to SproutCAM. Okay, how to find the TCP of this tool? After we have calibrate, we have to go to startup, tool and base management. Then we go and find, okay, this one we can closing this one. We have to find tool number 6, which is this drawing pens. And we try to look at the transformations X, Y and Z. Usually we just take the Z value and put it into SproutCAM. So tool number 6.
Okay, so if we jog the robots, we clamp the pens on the robots and we go to the directions that we want to set it as an origin, for example here, and this is the result that we have: 281.97, 288.96, Z is 174.95. So what we're going to do right now is we're going to, at the base setup here, click these buttons. Now as you can see, we can drag if we want. There's a certain value here. Either we can click here to import our value. So we have 281.97, 281.97, 1, 288.96, and we have the Z, which is 147.95. Let's check this one. Yes, 147.95. Okay. Oh, there's a bug happens here. Let's just save the file first. Save the file. Always remember to save after you did certain things. So this is just a sample drawing. Let me just restart my SproutCAM. Okay, back to SproutCAM. Now we have our drawings and our material ready, and the setup is ready. Now as you can see the N1 here, which is the point that we pinpoint just now. Okay, so this point. Okay, after this we will go and select a strategy 2D contouring. First we will go to the tool and we change the tool to drawing tool, and it's tool number 6. This one will be depending on the tool that you set it as the tool. This one I would like to use a conical mill, 12 mm, degree angle, 2 mm tip radius. Yes, 30-degree angle, radius about 20. Anyway, this is not important because we just try to make the pen as close as possible, but the result will be depending on the real pens that we attach on the robot. But the most important thing here is the overhang, which is also the TCP. Okay, as you can see here. Right now, what we're going to do is we have to input the correct TCP on the Z-axis. So just look at the picture that we have here and try to locate the TCP value. Okay, which is this one. We have 95.09, -1.1, and 214.52. Now, don't worry if that X result is different because when we do the TCP, we will get an error rate there. So TCP itself might not be very accurate. Okay, but for this one, we just want the Z-axis. So here it's key 214.52. Now as you can see here, the X value will automatic change. It's just 0.5 mm difference. This one is 95 and this one is 95.5, so it's still acceptable, and we just use this as a drawing application, so the accuracy is really not that particular here. Right now we already have our tool and our base ready. Next we can just adjust our speed. The most important speed here is the working feet. Okay, continue. Right now we have to set up our working feet 50,000 because the robot will be jogging in velocities, which is meter per second. If we convert it, so meter per second to mm per minute. Now you see that there is a difference speeds used in robots. Robot is using meter per second, which is the velocities, and in machinists we're using mm per minute. If we're using mm per minute, it will only equal to 0.003 meter per second in robot, which will happen very slow. So what we're going to do is we try to improve the speed here by putting a large value on the working feet. Okay. After we set up the tool and the feet, right now we're going to set up our setup. Okay, why this is important? Because right now the tool is pointing slanted. If we go to the job assignment, which is what we're going to select it, no, this one, as you can see here, if it's going to work, it will work the way slanted. This is not what we want. So what we're going to do right now is we're trying to make the setup correctly. Okay, so the tool supposedly to be pointing to go to front view. This tool supposedly to be pointing downwards, which is vertically to the workpiece, so perpendicular. So what we're going to do now is we can also use this method, click to pick. so we just pick the z-axis downward. Okay, this is not very accurate. We want that down. Back down. No, it's not great. Top view vector. That is also incorrect. Okay, we can't find the vector correctly using these methods, so we will just go and use these methods. Manual 90, that should be 90, 0, 0, oh sorry, this one should be 60 degree. Okay, after we define the setup, okay, so as you can see, the pen right now is pointing downwards to the work. Then this one is good to go. Then okay, we select again. Okay, so this one we will select the elements that we want to draw. We just select curve. Then you can always find the things that we want to draw. Right now it's under design tool. The design tool, we have this one. So the text is the one that we want. So just select it. Okay. Oh, so we accidentally select different things. We can just delete and just do the things that we want. Okay. After this finish, we just go to the strategy. Select this as a count. We just want to do one, so it's one count. The top level should be 0 because it's starting from the top. And negative 1, sorry, should be negative 0.15. Okay. So I just go to a depth of negative 0.15. Okay, this should be done. Check part, skip it, save motions. Okay, so we have a safe level of 20. So this is how the pens will try to move from P to P. So the pen will move P to P to this 20 before it drops downwards quickly by using a linear. So this is what we set up here. And also the features level, I use the same as the safe level here. Okay, then for the transitions, we were using by level and 5 mm away. Okay, after we done this one, we just click the run and link. Okay, as you can see here, now the blue line is transitions to the next point. Okay, the red line is the P2P rapid motions. Okay, after this we will just go to simulations, try to reduce the simulation speed, and you can press the run button. Now the robot will simulate the motions. You can speed up simulation here. Okay, so done. So this is the result. If you want to reset your simulation, just press the reset buttons here and you can just play again. Okay, you can also stop your simulations and try to look at all the points here. You can elaborate it, and when you click it, you can see all the step motions that it go. Okay, here also same, you can just press this one, to skip all the steps. Okay, so this one is for your study purpose. However, if you are satisfied with the result, you just go back to machinings, click the post process, and we try to select the KUKA post processor here under the system folder. So we select KUKA robots SPPX, this one. Then we go to the NC file name, press this one, open dialog, select the place that we want to save, for example desktop, and try to put your name, your program name. Okay, so in KUKA we cannot put space, so to replace that we will put as a underscore, open, run. Now after run, you will see that is the program ready for you to post in to post into robot. Okay, and we can click the external editor here to edit our program. So for example, we try to increase the velocity, we can go into 30, we can just remain 20 for the accelerations. Base data, if we want to use the temporary base data, we can just semicolon so that the system doesn't read this one, read the second line instead. Same to the 2. Okay. So the system will take this take this command into account instead of it reading from the library of KUKA. And we can also change the velocity CP if we want, so that it can speed up the process. Okay, so maybe this one is 0. We can do it to 1.5. This one we also can change it. If we feel that this is too slow, we can always change it. Okay, so we can also add a PX home here if we want. Then this program is good to go. Just Ctrl S to save it. Okay, now we have this SRC file ready to post to the robot.